This is Professor Rogers. In this presentation, we look at one-way ANOVAs. ANOVA stands for Analysis of Variance. A one-way ANOVA is a bivariate statistic used when there is one numeric variable and a categorical variable with three or more categories. It allows for more categories than a t-test, which is limited to two. The one-way ANOVA is an expression of the general linear model. For our example, we look at the violent crime rate by region. The violent crime rate is logged due to skewness in the distribution. The South has the highest violent crime rate. In the video on independent sample t-tests, we established that the South has a violent crime rate higher than the rest of the country. In this example, we look at differences between all four regions simultaneously. In both SPSS and PSPP, the path for the procedure is analyze, compare means, one-way ANOVA. As with other procedures, the dependent variable is entered in the box on the top right, and a box on the bottom right is used for a categorical independent variable. The independent variable is here called a factor, which is language that sometimes, but not always, is used to refer to a categorical variable in some software packages. I also recommend requesting descriptive statistics by group. In SPSS, you can request this information using the options box. In PSPP, the information is requested by checking a box on the bottom of the command dialog box. The output contains two tables. The first table is descriptive statistics for each region. Southern states have the highest violent crime rate, and northeastern states have the lowest one. The second table is the ANOVA table, which tells us the statistical significance of the model. This table is the same ANOVA table that we see in OLS regression. The total refers to the total sum of squares. This is the distance of every observation from the overall mean of the data. Between groups is the equivalent of the regression sum of squares, and is the distance of the predicted value from the overall mean. Within groups is the residual sum of squares. In this case, it is the measure of the distance of each point from its group mean. The rest of the table is exactly the same as what we find in the regression ANOVA table. The null hypothesis is that all the regions fall within the same confidence interval. The null hypothesis is rejected if the significance level is less than 0.05.
SPSS has some features not present in PSPP that allow SPSS users to explore the analysis deeper. The first is the Levene's test for homogeneity, which can be selected under the Options button in the dialog box. Just like a distribution may or may not be normal, so also a distribution within a region may or may not be normal. The Levene's test checks to see the similarity of the variances across each category. The null hypothesis is that the variances are the same, and homogeneity is absent only if the p-value of the significance of the test is less than 0.05. In this example, the p-value is 0.304, so homogeneity is present. Many statisticians do not like this test because it is not clear what to do if homogeneity is not present. But from my standpoint, the test provides a way to learn more about the data. An additional option is the means plot, which is a graph of the means by categories of the independent variable. Here we see the higher value for region 3, which is the South. Finally, the dialog box has a button called Post-hoc, which creates a table allowing us to compare the mean and standard deviation for each region with every other region, and also tell us whether the difference between means between each combination is statistically significant. To use this approach, we must select one of the algorithms used to help to determine the difference. Here I use the Bonferroni approach, which is a commonly selected approach when variances are established as equal by the Levene's test. In our analysis, we learned that the only regions with statistically significant differences are the Northeast and South. These differences appear twice, once in the results for region 1, the Northeast, and once in the results for region 3, the South. Like the Levene's test, it's not clear what to do if the differences are not statistically significant. However, the comparisons let us understand the data more, and they may suggest ways to combine categories in order to reduce the degrees of freedom used up by our model. For example, one might look at these results and wonder whether it is worth keeping both Midwest and West in the model. Perhaps these two categories could be combined since they do not appear to be driving the significance of the results and do not appear to stand alone. Nonetheless, I want to underscore that a decision to combine would be based on the judgment of the researcher. If, for instance, your theoretical framework or hypothesis was about the uniqueness of the Upper Midwest, you would not want to combine Midwest and West. You would need Midwest standing alone. You might also be simply interested in all four regions anyway, in spite of the results. The one-way ANOVA is a form of the general linear model that allows us to determine whether there is an association between a numeric variable and a variable with three or more categories.